I'm Craig Jensen. I'm a developer and I work on the WePause team.
What is WePause?
WePause stands for Windows Embedded for Point of Service. And what that is Microsoft's standardized operating system for the point of service or point of sale industry.
Okay, so how is that different to Windows XP Embedded, which I guess is in the same family of embedded products?
Yeah, so WePause is based on XP Embedded Service Pack 2. The difference is the true embedded product is a real componentized operating system. And you have to choose components, build an image, and deploy it and do all this stuff yourself. Whereas WePause, what we've done is created the image ourselves. I mean, we've built the image and we built a nice setup wrapper around the image. So it's a much easier to install, much easier to configure operating system. You basically stick the CD in, answer a few questions, just like XP Pro, and it installs itself, and you're good to go. So it removes all the hurdles of building the image.
So the main difference is that Windows XP Embedded is componentized. You get to pick and choose exactly what you want and then build and deploy that operating system image. Whereas with Windows Embedded for Point of Service, it's an installation process. So in, I guess, a typical 30-minute period, you've gone from installing to having a booted and running operating system image.
Yeah.
Okay.
And you also, another advantage is you get a standard core image, where with the embedded, you have to choose the components you want. So what ends up happening in the embedded world is that every retailer will build their own operating system with their own set of components. And then when you build applications for that OS or that set of components, it may or may not run on another image.
Mm-hmm.
So WePause brings a standard image, whereas it makes applications and those kind of things easily transportable across, from one company to another.
Okay. So in effect, you're defining a preset set of APIs, a preset set of technologies, and a very well-defined application layer. So it makes it easy for one point of service, point of sale developer to move an application from one POS system running WePause to another system also running WePause. Where on XP Embedded, they can't guarantee that the underlying technology is going to be there.
Exactly.
Therefore, their application may not run.
Yeah. So if you're a software vendor and this is your business to build applications, you end up having to sort of one-off them for every client. Where now you can build a standard app, and maybe just customize the UI for each client or something. But at least you can guarantee the app will run on, as long as they're using WePause, it'll just work.
Okay.
So the whole point of WePause is just to make it work, make it easy.
So is that the end of the story? It's just a standalone install?
No, there's more than that. So that's the OS part. Another thing we ship with WePause is something called Pause for .NET. And what that is a managed API layer to make it really easy for applications to use Pause devices.
Okay.
And by devices, I'm talking about things like barcode scanners, line displays, all these toys you see here. Basically everything that you plug into a machine to make it a point of sale, point of service terminal.
You've got an interesting set of bits in your office.
Yeah.
What exactly do you have here?
The hardware?
Yeah.
Yeah, well, so these are cash drawers, a couple of different models. This is the Pause printer. This is a little line display, 2 or 3 line display. This is a coin dispenser. Just drops coins out. You see those at McDonald's and some.
Does it work?
Yeah, it works. I'll write some code. We'll show you how all this stuff works together. This is a little scale, another line display, some scanners. Here's a card reader, credit card reader. It's called a MSR, magnetic stripe reader. There's probably other ones, but yeah. Why don't we write some code? I'll show you how easy it is to write an application that uses some of these things.
Yeah, code's good. We like code.
Yeah. Okay. So let me bring up Visual Studio. And we're doing this completely from scratch here, so I'm going to create a new project. We'll just make it a C# Windows application, call it Demo 1 or something. So Visual Studio has basically brought up the core components for the application. First thing I need to do here is go and add a reference to the point of sale assembly. So let's see.
Where does that come from?
Well, it's part of WePause. So if you install the SDK, which is part of WePause, on your machine you will get you know, this assembly installed in your program files folder, and you just set it. You know, you need to reference it when you're using it. So we find point of service. Where we got it in Microsoft service. Okay. And go to the SDK, and there it is. Microsoft.pointofservice.dll.
So does this mean that I need to write all of my code in C# or VB?
No. Well, you need to. It's managed code, so you do need to use one of the managed languages. But you could any managed language would work. C# or VB. Managed C++ would also work. J# would work.
Could I call
got
this?
A lot of choices.
Could I call this from native code? Win32 C++ calling into managed code using like a COM wrapper or something like
You
that?
probably could. I mean, it wouldn't be the easiest, most elegant way to go, but yeah, you probably could expose these things as COM objects or something. You'd have to write all the code to do that.
Right.
It's not the solution we would recommend.
Right.
Yes.
Well, if you're looking
Probably
for
possible.
rapid application development, then managed development is definitely the way to go, right?
You can't beat it for that. Okay, so let me just bring up the code here. So we're going to be using the point of service namespace, so I'll add that. Okay. Now there's one main object in the point of service namespace. It's called POS Explorer, and we're going to use that for a couple different purposes. The first one is for querying for different devices POS devices that are attached to the machine.
Okay.
And what we'll do is we'll query for the devices. We'll find the one we're interested in, and then we'll use POS Explorer to create an instance of that device.
Okay.
And then we can just write code against it. So it's that easy.
So when you're writing the application code here, do you have to know in advance about the exact peripherals that you're going to be attaching onto your point of service device?
Well, you'll have to know obviously what peripherals you want to use. I mean, I guess that's pretty.
But you're talking about the class of device rather than the specific
you need to know
manufacturer.
the class of the device, but not the manufacturer. And that's something we'll show here with plug and play, which is one of the real cool elements of. Oh, here's Janine.
Hey,
So here's Janine Harrison. So what do you do here at Microsoft?
I'm the product unit manager for this team, and the work that you're seeing now demonstrated is work that our organization has created.
Okay, why did you create this? What was missing, and why do we need to do this?
Oh, wow. I take it back to my first day at Microsoft when I started here, and I had to take the box cover off, and I had the piece of paper, and I got down on the floor, and I pulled my network card, and I changed my jumper settings, and then I went into my INI file, and I changed my memory settings, and then I looked to find where my interrupts were. And the place where we are today, in retail peripherals, was that bad.
Right.
Literally, it hadn't changed since 1988 or beyond until they came out with an interesting model in 95, but missed the whole plug and play era of I shouldn't be able to plug a camera into a PC today and have it find it and know it's a file system, and plug a scanner in to a retail point of sale one and not even know that I plugged the scanner in.
Right.
Why should we have our customers having to deal with memory conflicts, IRQ conflicts, basically opening the box again and changing the jumper settings? In 2005 and 2006.
Right.
We can solve that problem. So, Craig solved that problem.
Yeah, well,
Right?
we're working on it.
It's not free, but we can fix it.
Right. Well, we're just getting a demo now of building an application in Visual Studio that takes advantage of a couple of retail peripherals. I guess that's something like a barcode scanner, and what was the other one? A two-line display.
A line display and a scanner, yeah.
Right.
You can do some other ones if you want.
Well, how long is that going to take to write the
Not
code for
very
two
long.
devices?
Not
It
Well,
won't take very long at all.
Well, in that case, maybe we'll have time for a couple of additional ones as
We can
well.
write
All right, I gotta go.
Thanks for dropping in.
But, you're welcome. Have a good time.
All right, thanks, Janine.
Okay, so where were we?
Okay, so back to the demo. So I was talking about the sort of the main object that we're going to use, and that's the POS Explorer. So I'll just create one of these guys. And then we're also going to start out with the line display. So I'll go ahead and add an object of type of line display. Okay. So down in the constructor here, what we'll do is we'll create a new instance of POS Explorer. So just new Pause Explorer. I need to pass in a reference to the window, because this is a Windows Forms thing where we're going to be receiving some plug-and-play events and some other events, and we'll probably maybe be updating the UI, so we need to get those events marshaled onto the correct thread.
Okay.
So just by passing in an instance of the form that we're going to receive the events on, Pause Explorer takes care of the rest. Okay, so now what we want to do is use this little Epson line display here. So there are several ways to determine what devices are attached to the machine. First of all, you can know the name of it. In this case, we know the name of this thing that we want to use. So we can just basically load it by name.
Mm-hmm.
Another way we can do it is there's a Get Devices API on Pause Explorer, which will return a collection of all the devices. And then we can enumerate through the list, and we can look at their names and look at their properties. And
So where does that list come from? Is it through plug-and-play IDs, or what exactly is that? Where does it come from?
well, it's actually a list of, so when you write a service object, which is the piece of code that implements the interface for line display or scanner or whatever kind of device it is, we've added a way to where you can add some attributes to these classes to describe what they are, what the manufacturer is, what version they are, and some
Right.
information that we need to know about
So each
how to load those things. The hardware ID is another
each
one.
device needs to have one of these service objects.
Yeah. So when you buy a peripheral, you will, along with it, you will get the drivers for that peripheral.
Mm-hmm.
So that comes from the device manufacturer. We have done some things to ease the burden of writing these. The old way to do it used to be you could write a COM object or something, and you had to basically start from scratch, do all this COM magic that's not trivial by any sense of the word. But now with managed code, it becomes a lot easier, just because managed code is easier to write, and plus we have created a set of base classes that implement a lot of the functionality, because a lot of these devices, they have a common API and a common event model and a common error handling model and these kind of things. And in our base classes, we've implemented all those common features.
Yeah.
So it's really easy to write. You can literally write a service object in probably 100 lines of code now, where it used to take maybe thousands.
Right.
in the old days. And by doing that, you get a lot of
So
things.
how much time typically would somebody spend implementing something like a new barcode scanner into a point-of-sale system, and roughly how long does that take now? You mentioned number of lines of code, but if
I got into this business a little. I've never actually written one in COM, so it's hard for me to give you an estimate. But it's probably weeks or months or something to
Wow.
create one from scratch. Where nowadays, we had a couple training events with partners during the development cycle of WePause, where we brought customers in and we gave them some talks about how to create these things. And then we had a lab session in the second half of the day. And there was half a dozen customers who actually had brought their hardware, had never seen WePause before, and they had working service objects in half a day
Wow.
of lab.
Wow.
So it's really very easy nowadays.
Wow, that's incredible.
So, and that's the goal of WePause, is just to lower the burden, make it very easy and to write these things, both applications and service objects.
Right. Okay, talking about applications,
Okay.
let's get back to the code.
Back to the code. So what we're going to do is use this line display, and we'll, so we need to create an instance of it. Actually, first thing we need to do is get something called a device info, which contains information about the device, and then we'll use that to actually instantiate the device.
Okay.
So create a device info, and then we'll use Pause Explorer again, called the Get Device API, and that will take the type of the device, in this case it's line display, and the name of the device we want to create. We know the name in this case, it's Epson Display. And that will give us back one of these device infos. And now we can use that device info and we can look at properties on it and stuff like that. And we also use it to instantiate the device. So we're going to say, to actually instantiate the device, we do and we'll use Pause Explorer again, and we'll call create instance this time, and we'll pass in the device that we want to create. And at this point, we have an instance of the service object for this line display. Now we can just use it.
So once you have that, what kind of things can you do with it?
Well, we defined a common interface. We didn't actually define it, I guess. It's based on UPOS, which is the industry standard, Unified Point of Service.
Mm-hmm.
What we did is we made a .NET version of UPOS. So it's a well-known set of interfaces. Each device has its own interface. And once you create an instance of this object that implements that interface, you just call methods on the interface and talk to it. And,
right.
So there's a standard model for opening and enabling a device, and that's what we need to do first. We'll say display.open. So that opens it. And then we say we need to claim it. So a line display is what's called an exclusive use device, which means that only one application can use the device at any given time, which makes sense. You probably wouldn't want two different devices writing text on there, or two different applications writing text at the same time.
So what have you passed in as a parameter there?
So it takes a timeout. So what happens is tries to claim it for exclusive use, and it'll wait this many milliseconds, so 1 second in this case. We know that no other application is resident right now, so I could pass in 0 if I wanted to, but I'll just pass in 1,000. And what happens if you can't claim the device within 1 second, it will throw a timeout exception back to you. So
okay.
You can sort of control how long you want to wait to get exclusive use. Now we've got it claimed. The last thing we need to do is enable the device. So we set the device enabled property to true. And at this point we're basically ready to use the device. So I'll just output some text. You call display text. You give it the text you want to show, and just do the good old hello world. Okay, and at this point, if I haven't made any typos, we should have a very simple application that uses the line display and says hello world, and there we go, hello world.
That's pretty
That
cool.
is probably, 10 lines of code or less, and we were actually using the device. The next thing I can show you.
So it'd be just as easily to throw up there, special offer on Coke or something like that.
Sure, whatever you want, just text. Next thing I want to talk about is plug and play events, which is really at the heart of WePOS and POS4.net. Bringing plug and play into this industry, making it just like a desktop system where people are just used to walking up to their PC with a digital camera or printer or whatever, and plugging the thing in and just making it work, and having the PC recognize it just works. And that's what we want to do. We want to bring that to the point of sale industry as well. So our good old Explorer object has a couple of events on it. One called device added event, and the other one is the device removed event.
Mm-hmm.
And what happens here, I'll just go ahead and hook up event handlers for this, and Visual Studio can make this so easy. Just hit tab a few times. Okay, so I've added a handler for the device added event, and what I'll show you is how you can make use of a scanner and a plug and play event. So what we're going to get in this device added event is one of these device changed event args parameter, which will contain a device info, which is the same device info we used when we instantiated the scanner,
Yep.
or the line display, excuse me. So we can basically just use that device info to create an instance of the scanner. And we don't, at this point, even care what the manufacturer is or who it is, or it's just a scanner. It's like every other scanner. We'll just use it.
Right.
So I'll put in a little bit of sanity check here to make sure that what we got is indeed a scanner. So look at the device info, and one of the properties is the device type. So I'll just look at that and make sure it's equal to scanner, which is what I would expect it to be. So if it is a scanner, I'm going to use POS Explorer again to create an instance of that. But first I need a scanner variable here. So let me go up and add a scanner variable. I'll come down here and I'll assign to that. And then Explorer create instance again, and give it this device info. And at that point we've got a scanner created, or instantiated. Before I do that, well, it doesn't matter, I guess. Now, just for fun, just to show, so we can see, have a visual cue when this happens, I'm going to put up the name of the scanner on the line display. So I'll say display, I'm going to first clear it off. Clear text. And then I'll go and do display dot display text. And we're going to say device added. And then add the name of the device, which is again in this device info object that we got back. We can use the service object name. It'll be good enough for now. Okay, so that will show the service name of the service object on the screen. And now let's go ahead and get the scanner ready so we can scan some things. We need to do the same open, claim, enable as we did with the line display. Device enable goes true. A scanner is an input device, so there's a couple more things we need to set before we'll actually get these events. The way the eventing model works with an input device like a scanner is you scan a barcode and it will go into an internal queue in the service object. And then the application has to request, they're called data events, but they're just events that will send the actual scan data back.
So you do get an event back when that occurs?
Yes.
Okay.
Well, when you do the scan, it goes into the queue, and then the application can set a property and tell it, I want to get an event now.
Right.
So the events are sort of fired when the application requests them. So I'm going to go ahead and...
So can an application request an event and then in effect just sit there indefinitely waiting for a scan event to actually occur?
Yeah, and it won't wait because the event will come in on asynchronously.
Yeah.
But yeah, we'll do that right now. First of all, we'll sign up for the data event. So we'll add a handler for a not data count. Data event. We'll do plus equals, and then we'll add a handler for it. I'll go fill that code in next. So now we've signed up for the data event. And now the thing we need to tell the service object to send us the data event when it gets it. And there's a property called data event enabled. When you set this property to true, that means give me the next data event in the queue or the next one that comes in the queue. So if there's currently none in the queue, the very next one that gets added to the queue will just immediately be fired to the app.
Okay.
So by doing this, we're essentially telling it to just wait for the next scan event and send it to us as soon as you get it.
Okay.
The scanner API has, by default, there's a property called decode data. So you get the data back by default in a sort of proprietary format, the raw data that comes off the barcode, and that is kind of dependent on the hardware itself. But there's a way to actually tell it to decode the data and give me just the barcode symbol, for instance, in a decoded format. And since we're going to be displaying it on the screen on the line display, we need to have it in the decoded format. So I'm going to set the get exact data. It's decode. Yeah, decode data. I'm going to set that equal to true, which tells it decode the data and give me the decoded data instead of the raw data. Okay, so that's all set up and ready to go. Now, what do we do when we get the data event? We'll try and display it on the line display. So we'll say display, we'll clear it again, and then we'll display text, and we'll say scanner dot decoded data, or no, data, I think it's data label. Scan data label, that's nice. The one thing about this though is that, I don't know if you can see that on the screen, but scan data label is actually a binary property, because there are some barcode symbologies that are two-dimensional.
Right.
So they come back as bytes instead of text, and we need to show text. So we need to do one more trick to get to turn this binary into ASCII. And there's actually something real cool in the system.text, there's the ASCII encoder object that we can use to just decode this. So we'll go ahead and here. ASCII encoding. Okay, we'll just create one of these guys. And then inside here, we'll say encoding dot get string. So that'll decode the binary data into a string that we can show on the screen. So that should be all. Oh, one more thing we need to do is the way the API works is once the service object fires a data event, it'll set the data event enabled property to false.
Okay,
So it only fires one at a time. So
right.
Just so we can do more than one, we'll just go ahead and re-enable it here. Data event enabled equals true. So next one comes, we'll show it too. Okay, hopefully I didn't have any typos in there. Let's see if it compiles and runs. So what did I do wrong?
Oh,
No,
you haven't actually created the scanner object at that point.
Oh, didn't I create it?
That's down lower.
Okay. But it has some typos, I guess, where I'm here.
So don't they need to be moved down to where you instantiate the scanner object on the plug and play event?
Yeah.
That's not
Why
where you
did
are.
I put this up here?
So
I guess
yeah.
I was typing in the wrong spot there. Right. Okay, so we've created it, open, claimed, enabled, set up the data event. Yeah, I guess I came back to the wrong spot, didn't I, when I created that data event? Okay, yes, of course. Create the scanner, open, claim, enable it, set up the data event, set data event enabled, and decode data. All right. Hopefully that will work.
Okay.
Okay,
See
here we
hello
are.
world.
Hello world again.
Okay.
Now,
So if you drop out the way just a second, we'll
Okay.
be able to see the.
you see them both now?
Yep.
Okay, so what I'm going to do now is just a standard little USB scanner. I'm going to go ahead and plug it in. System recognizes it, and we got our device added event from Project Explorer, and we're showing that the device was added. It's called example scanner. It's example scanner because this is one of the SDK sample, one of the pieces of SDK sample code that we include with our SDK. So there's actually source code for this guy that you can look at to see how easy it really is to write one of these things. Okay, so next thing I'm going to do is go ahead and scan a barcode here. And look at that. We've got our data event. It's decoded. You can see it on the screen. You can scan several different ones, you know, Hotman, whatever.
What does that say? Ah.
There it is. So now that's really cool. You know, we just used the scanner without telling our application anything about the manufacturer, any details. A scanner got attached and we used it. Let's just say, you know, this is a year or two down, or maybe this device broke down or whatever. Sometime in the future you decide, or maybe you just saw one of these really cool wireless scanners and you thought that would be cool. I need to have one of those for my application. So it'd be really cool if you could just unplug your old broken down one here, take your new wireless one, which is a different manufacturer and all different, plug it in. And, well, look at this, we just added an HHP scanner. Look at what happens if we try and scan with it. Oh wow, it just works. That's the whole idea here, is behind WePause, is just to make it work.
So no additional coding. It's just
No.
plug it in. It gets detected, and you're straight off again.
Yep. Scanner's a scanner, and if you support plug and play, it just works.
Okay. Now,
That's cool.
I know exactly what the people watching this video are thinking right now. They want to see some change drop out of that change machine over there.
Oh yeah, okay. We can do that. Let me stop the application here. Oops, did I hit stop? I didn't hit the right one. Running this on the debugger here too, so it's a little slower than it normally would be. But okay, so we have, I think it's a Telequip coin dispenser over here. So to use that, we'll just create a variable for coin dispenser. Okay. And then Why don't we go ahead and add a button or something on the part of the form here and text box. So we're going to tell it how much change we want to dispense. So dispense. I'll just call it dispense. And then in the text box will be the amount of change, and by default I'll just put it at 25 cents. So I need an event handler for that.
So there's no logic needed in the application. You just send the amount and
yeah, that's the way the
mechanism then
API
pushes it
works.
out.
You do your open claim enabled, and then there's a dispense change API, and you
Right.
tell it how many pennies, essentially, how many cents you want to dispense.
Okay.
So let me make sure I'm in the right spot. So I need to create an instance of the service object. So I'm going to go do the same thing here. Actually, why don't I just cut and paste just to make this a little quicker. So I'm calling. I need to variable. So I'm calling get device again, but this time it's going to be coin dispenser, and the name of it is Telequip coin dispenser, I believe. And then I'm going to cast that to coin dispenser. I guess this needs to be, what do they call it? Dispenser. So all these become dispenser. Okay. So I've, in the constructor, created an instance of the device, open claimed, and enabled it. And then down in the handler for the button click, I'm just going to say dispenser.dispense change. I need to give it the amount, which is an integer, but I need to get that from the dialog, so I'm just going to do an int.parse. And let's say it's textbox 1. Textbox1.text. I'm going to assume people type integers in there. Obviously, you'd want to do a lot more error handling than this in a real application, but for demo, this should be fine. Wait for our application to come up here. Okay, so now we got this little form with the amount you want to dispense, and I'll just click it on one. Sure enough, out comes money. There was some in there.
Okay.
If you want to
Click it
change
again.
this,
Click it again.
19 cents. Oops. There comes 19 cents. So it's just that easy. One more thing I can show you that you get for free with using POS4.net and the base classes is that we've done some things sort of behind the scenes to make management of the POS machine easier. One of them is we've hooked in our base classes with Windows performance counters.
Uh-huh.
So the idea behind this being that in a large retail store maybe has a lot of checkout lanes, and it would be nice to have somebody that could sit in the back room and run a monitoring application and go look at these performance counters on all the terminals and see things like how many times how many errors have occurred, or how many scans have occurred, or how many magnetic card swipes, or so basically monitor the state of all these devices, because there could be things like maybe after 10,000 card scans you have to go clean the device or do maintenance or something.
Right.
So we've integrated this into performance counters. Just let me go ahead and open up perfmon, and I'll use this scanner again. So get rid of these default ones. Now I'll use this wireless scanner again. Make sure it's okay. It's working. Now I'll go add a counter. You see that?
Yep.
Okay. And in the list of counters will be, I think this one is called HHP, so let me find the HHP scanner.
Yep.
So there's your performance object. You'll see there's 3 counters defined for this device. So there's a set of standard ones for each device class, and then people can extend those. So if a manufacturer wants to create their own counters, just a matter of calling a create counter API and then increment counter whenever they want to. So it's really easy to extend them. But you get these three built-in default. You don't have to do anything.
Yeah.
Just happens if you use our base. So I'll add the counter for good scan count. And close this out. Let me just go ahead and maximize this. So that color's not very good. Can you see the yellow color here? Let me highlight it. Maybe it's a little better.
Yeah.
Okay, so far we've done 65 scans. And just to demonstrate how this works, we'll just... No, it's not going to scan. Okay. Scan a bunch more. And you see how this is live, so Perfmon will just pick up all the scans. Again, developer doesn't have to do anything here. It just happens behind the scenes when you use our base classes. So that's another way that we've tried to lower the maintenance costs and the cost of ownership and all that kind of stuff.
Okay. So the name of this product is Windows Embedded for Point of Service.
Yep.
Why point of service? Why not just point of sale?
Well, point of sale was kind of the old terminology where you used to just go someplace and buy things. You think a cash register or something like that. Where nowadays retailers are getting more and more into the service kind of thing. So you see these automatic checkout lanes, and you see devices where maybe they can check the price of certain things, or order things from a catalog, or do things above and beyond just simply purchasing something.
Mm-hmm.
So it's the same devices and all that, but it's a little bit of a different paradigm shift in how the devices are used.
Right.
Instead of simply buying something, you're now not only buying but doing all these other things with the same devices and same applications.
Okay. Now, since the operating system is Windows XP at the core, does that mean that all of the same maintenance and updating technologies that are available on the desktop?
Yep, exactly. Yeah.
And things like antivirus and all those kind of things you'd expect to run on the desktop also run here as well.
Yeah. Almost across the board. Our image size. We're smaller than XP Pro, but we try to include pretty much everything every component that people would need to write a point of service app. So we have, Windows Update is part of the system. You can get automatic updates just like XP Pro.
So roughly how big is the image size when you install it?
So the minimum size, I think, is somewhere around 380 megabytes.
Right.
If you do a minimum install.
Okay.
And we do have some optional components.
Mm-hmm.
Things like IIS and Windows Media Player and a few others.
Okay.
So in setup, you'll see the screen, and if you check all the optional components and add those, you get somewhere in the area of maybe 500 megabytes.
Right.
So, yeah, we're not a tiny OS, but we're not as big as XP Pro either. We're kind of somewhere in between.
But the speed of development that we've just seen is obviously a real plus for Windows Embedded for Point of Service.
Mm-hmm.
Not only for the application developer, but also at the store level as well. You gave a good example here of one barcode scanner going down and just swapping that out for a completely different manufacturer, a completely different model,
right.
And within seconds it's up and running again. That's going to be a big bonus for the store as well as the developer.
Yeah, just like Janine mentioned earlier, the old days where you'd plug in your little serial port device, and then you'd have to set the baud rate and make sure all these things and the dip switches are set right, and everybody remembers those days. But
So does that mean that all the devices we work with have to be USB devices, or are some of the devices non-USB devices?
No, they don't have to. Yeah, we can still support the old ones, but we can't do anything about the setting, the jumpers, and all those kind of things. That if you have legacy devices and you want to use them, you can.
Mm-hmm.
We actually have another part that I didn't mention about POS4.net is we support interoping into OPAWS.
Oh, okay. So
what OPAWS is, I mentioned UPAWS being the interface specifications for all the devices.
Mm-hmm.
And we're POS4.net's the .NET implementation. There's also another implementation called OPAWS, which is OLE for point of sale. So it's a COM implementation of this, basically the same specification. That's been around for about 10 years. And so there's a lot of those objects out there, and a lot of them work and that kind of thing. And what we've done is added a layer to POS4.net where we can actually wrap these OPAWS objects in managed .NET objects.
All right.
So you can use them just exactly like they were if they were a real, true managed object.
Mm-hmm.
You won't get all the benefits. It's obviously you have to write the thing, which is hard.
Yeah.
You won't be able to hook into our performance counters, all that kind of thing. But the application will still be able to use them.
Right. Are the majority of devices these days moving away from like serial connect onto USB
Yeah.
or similar?
Yeah, definitely.
So all the
industry's
devices,
changing. So
all the devices we've seen today, the two-line display, the coin dispenser, the barcode scanner, they're all USB.
actually, the line display is a serial device, but
Okay.
the other ones, the two scanners and the coin dispenser are USB.
Okay.
So I guess we did do an example of both. So
Right. Well, that's good.
yeah,
Okay. Anything else you want to tell us?
I think that's about it.
Great. Well, thanks for your time. We
you.
definitely want to come back and hear about any advancements or new features or anything else you do.
Anytime.
Great. Thanks.
Thanks.